Hi everyone, just a quick little add-on here at the start of the video. In the rest of the video and at the very beginning with my voiceover, you might see and hear me have this labeled as 9.1.2. This is actually 9.2.1, which is what you can see on the screen right now. I mixed up the title when I was recording because the order in this chapter is a little bit weird, so we go from 9.1 to 9.3 back to 9.2, and I got a little mixed up. So ignore the title on the screen that's going to pop up after this, and when I say 9.1, ignore me there too. This is definitely section 9.2, and if that's what you're looking for, you're in the right place. Welcome to section 9.1, Quadratic Inequalities in One Variable. This is a section that tends to give a lot of people trouble. If you get it, it can be really easy, but if you don't get it, this is something that people really struggle with. So this is definitely a video that you're going to want to take your time through, and especially even more so, the second half of this, 9.2.2, is the one that you're going to want to kind of go through slowly, maybe pause, rewatch a couple of things to really get your handle on it. Before we get into the quadratic inequalities, let's do a quick review of some stuff from grade 9. So just a brief review. Say you were asked to solve something like 2x plus 5 is less than 17. Right, so this is a linear inequality in one variable, and you solved things like this in grade 9, and you've actually also solved them a bunch in this course, right, when we were doing restrictions and doing other things that involved inequalities. So to solve this, we just want to isolate x, same thing we've done before multiple times. We're going to subtract 5 on both sides, right? We're going to get 2x is less than 12. We're going to divide both sides by 2, and we end up with x is less than 6. So unlike our linear inequalities in two variables that we did in 9.1, where we had a whole range of solutions covering an entire area of the graph, right, combinations of x and y values, this is just x, and so it's any x value that fits this. And so you might remember drawing graphs for this back in the day. Oops. Right, so, and you would have done that using a number line. So something that looked like this. Right, so we have this number line. And so back in the day, you would have put a dot at 6. And to decide whether that dot was filled in or not filled in, you would have looked at your inequality symbol. So in this case, since it's just less than, not equal to, this would have been an unfilled dot. And then you would have had an arrow pointing in the direction of your answer. So if we want things to be less than 6, we want to be going left. And so this is how you would have graphed your answer to this for a linear inequality in one variable. But we're doing quadratics, so things are going to be a little bit different for us. In this video, we are going to look at how to solve by graphing. In the 9.2.2 video, we are going to look at how to solve algebraically. So you definitely want some graph paper for this one, and we're going to just kind of see how we can visualize our solutions to these things. So let's try solving one. Let's say we wanted to solve x squared plus 6x plus 5 is less than 0. So if this was an equation, right, x squared plus 6x equals 5, we could factor this and solve it pretty easily, right? So we could factor multiplying to 5, adding to 6, that's x plus 5 times x plus 1. And so when this was equal to 0, it was really easy to say, okay, well, if this thing equals 0, then one of those things has to be 0. And so you just set them equal to 0 when you solve. But if we want to be less than 0, that doesn't really apply anymore. There are ways to make it work in terms of thinking of positives and negatives, but it gets a little bit annoying going that route. So that's really not going to be how we actually want to solve this thing. So this is where graphing comes in. Let's see if we can visualize this. So if we're going to graph this thing, we probably want to get it in vertex form. So let's just complete the square real quick. I'm not going to go through the steps of that. So if you do complete the square with your x squared plus 6x plus 5, you're going to end up with something that looks like this. And you're going to finish off with something that looks like this. So there's our vertex form. So let's get ourselves a graph. Draw yourself, let's say, a 6 by 6 grid, and then get this parabola on it. You should know how to do that at this point. If you're still struggling with the graphing of parabolas, do make sure you come get some help or go back and check one of the previous videos, because it is something you're going to definitely need to know how to do for the rest of this lesson. So get your grid, get your parabola, then come back. All right, so I've got my parabola here. And so let's go over some things real quick. So remember, the parabola represents where y equals x squared plus 6x plus 5. Right? Focusing on the original function instead of the one that we kind of transformed it into. Just to prove a point, I'm just going to move that y to the other side of this equation and have this look like this, just because it's going to make more sense in a sec. Remember when we were solving by graphing back in chapter 4, when we wanted x squared plus 6x plus 5 equals 0, the way we did that is we looked at the intercepts. So these 2 points here are where x squared plus 6x plus 5 equals 0, right? It's when you're on the axis, because the axis is where y equals 0. So if you compare these two things, you can see that basically we've just swapped the y out for a 0, and so we're looking for the points where y equals 0. And that's great. So that's how we solved equations, but we're not dealing with an equation, we're dealing with an inequality. So if we look back up here, we don't want it to be equal to 0, we want it to be less than 0. So we need to look at this graph and tell ourselves, well, if this line is 0, where is my graph less than 0? And specifically, remember, this is kind of like y over here on this side of the equation. So we want our y values to not be 0, but we want our y values to be less than 0. And this is something that people really tend to have a little bit of trouble internalizing, especially because they try to compare things to what we did in 9.3, where we were graphing inequalities and we were doing all that shading. We're not going to be shading anything in these two lessons, right? We're not looking at areas here because we don't actually care about the y values specifically. We only care about x. If you look at this inequality up here, there's no y in it. So the y values aren't going to be relevant. The only thing that is going to be relevant is the x values. So we want all of the x values that make this inequality true. The question is going to be, which x values are those? So because we want our thing to be less than 0, so remember, this is the parabola, right? And we want the parabola to be less than 0. This is the only kind of y value that we care about, is whether we're above or below 0. So we want to find everywhere where the parabola is below 0. And specifically, again, we only want the x values. But remember, 0 is just the axis. So really what we want is all the places where the parabola is below the y-axis, or sorry, below the x-axis. And so you don't really need to get too in-depth into the reasoning behind why all of this is the way it is. The key thing you need to know is you're going to always be looking for where your parabola is either below, above the axis or below the axis. And you just need to look at your inequality to decide that. So in this case, less than 0 means below 0, which means below this green line here. And so the parts of our parabola that are below that line is this part of the parabola here, right? So this bit is underneath. So that's the part of the parabola that I want, but I don't want the whole parabola. I only want the x values. So remember I talked about that. We only want x values. X is the only thing I care about. And so if I only want the x values, I need to decide which x values correspond to this part of the graph. So this is what I want, and we need to find the corresponding x values. And the graph makes that pretty easy. So we just look at the graph and we say, okay, well, if my two x-intercepts are at -5 and 0, right? So these 2 points that we highlighted up here with the blue dots, then it seems like everything in between those 2 points, so from here to here, are the x values that correspond with where my graph is below that line. And so what we'd say is the parabola is below the x-axis, when x is between those two values. So -5 and -1. And so just like way up here back at the beginning, where we answered this inequality with a domain, right? With x is less than 6. That is a domain. We're also going to answer this one with a domain. But in this case, we're going to say our answer is when x is in between -5 and -1. We don't include the equals parts on these because we didn't have the equals parts in our original inequality. So if we had had the equal here, we would be including the equals in our answer, but since we don't, we won't. So this right here is our answer to our question. It's only those x values that are going to make this thing true. So let's try another one. So we're going to solve x minus 2 squared minus 4 is greater than or equal to 0. So first thing we need to do is graph this thing. So that's step 1, graph the parabola. So let's get ourselves a 5x5 grid, and we'll give that a shot. Okay, so we've got our grid. This is a pretty basic parabola to graph. So our vertex is at 2, -4. We've just got the basic pattern, which I'm not going to be explaining at this point. So if you are still struggling with graphing, make sure you go back and get a little bit of a review. And do make sure that you get a point, get points above and below the axis here, just to really help you figure out where you're going to get the answers that you want. Because remember, the axis, the x-axis specifically, is kind of our deciding point here. So we've got ourselves a parabola. Looks like this. Now that we've graphed it, second step is to decide whether you want the y values above or below the x-axis. And so you're just going to do that by looking at your original inequality. And this is really the key step here, right? So if you can't decide whether you want to be above or below the axis, you're never going to be able to properly answer the question because you're not going to know which part of the graphs give you your answer. So it's going to be the positive or negative y values, which again is going to be above or below the x-axis. So in this case, we're going to go back up to our inequality, and we just look at this. This is the only thing we care about at this point. So that is saying we want to be bigger than 0. And so if you're bigger than 0, well, that means you're positive, right? And if you're positive, well, where do you get positive y values? You get them above the axis. So again, we don't care about y values in a specific sense. I'm never going to be finding a specific y value. We only care about them in the general sense of is it positive or negative. So in this case, again, bigger than 0, above the axis means positive. So we want these two parts of our graph up here. And that's going to be our next step, is to figure out which part or parts, because it can be 2 parts, it can be 1 part, it can be no parts. So we're going to figure out which part of the graph fits our inequality. So if we look here, if we want this graph to be positive, we want it to be above the axis, well, this part of the graph is above the axis, and this part of the graph is above the axis. So it's those two parts of the graph that I want. And so the last thing we want to do now is figure out which x values, which domains, are going to fit those parts of the graph that we got in part 3. So we're going to figure out the x values, aka the domain, right? Same thing, that fit the part or parts that we just got. And so looking up here, again, we want these two pieces here, which means we want the corresponding x values, right? So I don't care about y values. So looking at this graph, again, we focus sort of on these intercepts, and we have to ask ourselves, well, do we want to be in between those intercepts? Not really, right? Between the intercepts, and here corresponds to the bottom part of the graph, and we don't want that. So we want to be going this way, because that's where that top part of the graph goes. That top part of the graph is going left, and it's also going right. So I want the x values that correspond to those two pieces. So if you're looking at this bit of the graph, this is 4 and this is 0. The right part of the graph over here, this is where x is greater than 4. And then we're going to throw the equals in there because our original inequality up here had the equals on it. This left part of the graph is where x is less than or equal to our other intercept of 0. And this bit in the middle, which we don't want, is where x is in between 0 and 4. But we don't care about that because we don't want to be down there. And so those two domains there are our two parts of our solution. So since there are two pieces, there are two parts to the answer. So make sure you include both and don't try to combine them together. That is something that people try to do sometimes. These are two separate parts and two separate domains. They don't get mushed into one. There's no way to mush them into one that's mathematically possible. Because otherwise you'd be trying to say that you're trying to find something that's smaller than 0 but bigger than 4, and well, that doesn't work. So our final answer to this question would be that x is less than or equal to 0, or x is greater than or equal to 4. And there we are. So I'm going to give you one more of these to try for yourselves, and then we will take a look at it later. So go ahead and see if you can solve negative x plus 1 squared plus 4 is greater than or equal to 0. So sketch yourself out a grid, draw out your parabola, and then figure out which part of the graph gives you what you want. All right, so I've drawn my grid and I've drawn my parabola, and I'm ready to figure out which part gives me my answer. So looking at our inequality up here, we want to be greater than a 0. So remember, 0 is this line, and greater than 0 means above that line. So the part of our graph that corresponds to that is this top part of our parabola up here. That's where the graph is above 0. And so we want the x values that fit with those parts. So if these are our intercepts, we want to be in between those intercepts because that top part of the graph is in between those intercepts. Quick refresher for you on how to write domains or ranges when you're in between two things. It should always look something like your smallest thing is less than, maybe equal, in this case equal, to your variable, which is less than or equal to your largest thing. Right, so try not to mix the order on those up. When you're doing domain and ranges, typically we put the smallest value on the left. So you really got to watch out for these, make sure you write them in the right way. In this case, our smallest value in that green part of my domain is negative 3. My variable is x. My largest value is 1. And so we just get this very standardized setup. Negative 3 is less than or equal to x, which is less than or equal to 1. And so that's it for solving our quadratic inequalities in one variable by graphing. So in the next video, 9.2.2, which is going to wrap up this chapter, we're going to see how to graph those inequalities without graphing, because sometimes it's not always going to be the most practical route. So once you're ready, go take a look at that.